These two issues represent two major projects. Can do that because we have three staff members I can thank, Tim and Paul and Chris, who are funded by the Ontario Trillium Foundation, and Doug Clark, who's a volunteer member of our board and the project manager of the Muskoka project. I think you'll see that the vision of the Friends of the Muskoka Watershed on this slide is actually quite similar and something the Muskoka Lakes Association should be comfortable with, healthy Muskoka watersheds forever. But our approach is a little bit different from that of other environmental organizations in Muskoka. We focus on generating the knowledge needed to solve environmental problems and then fostering the will needed to solve those problems. And we can take that issue, those required steps of knowledge and will generation, and think of that in a simple loop. So we have kind of a four-step model. We start by identifying the key watershed threats or problems. We always make sure we have a couple of scientists on our board. At the moment, that's me and Dr. Neil Hutchinson. And we keep in touch with the people that are monitoring the environment locally, but also read the global scientific literature. And for your interest, calcium decline and road salt have been highlighted as two issues by limnologists across the Northern Hemisphere. We then seek, anyway, the issues have to have three features in common. They have to be widespread. They have to be not being addressed, we don't think effectively by governments. And there has to be a role for the local citizenry in attempting to deal with those problems. So if the issue shares those three features, then we try and take it on. We next attempt to identify gaps in understanding that are needed to resolve the problem. Then we attempt to secure the resources needed to fill those gaps. That usually involves interacting with universities. And then finally, once we've generated that knowledge, which can take a few years, we do something that might be even harder, which is try and foster the will needed to apply that knowledge to solve the problem. And that would take us back to the start where we see if it all worked out. So I'm going to show how that approach, that little four-step approach has been followed for the issue of widespread ecological calcium decline. We all understand what osteoporosis is. It actually plagues 1.5 million Canadians, 10% of people over the age of 40. Given the number of participants on this call, I suspect that osteoporosis is something that a few of you might suffer from. We all understand that it has something to do with something going wrong with calcium uptake, calcium metabolism, calcium loss from our bones. Because we are, as an animal with a skeleton, 6% calcium. So in our lakes, there's lots of creatures that actually need more calcium than us. Crayfish can be up to 30% calcium. Snails and mollusks can be 30% calcium. Some fish need less calcium than us. Trout are only 2% calcium, but bass are 8% calcium. Other animals like birds and turtles with their shell that's actually an enlarged rib cage need a lot of calcium. So given that we have creatures that need a lot of calcium, if calcium levels are actually falling in the environment, then there actually might be a problem for initially aquatic animals with respect to calcium. So we stay in touch, the Friends does, with scientists in the region that are generating lots of data. So here from the wonderful scientist, Dr. Andrew Patterson at the North Environmental Science Center, shared these data on what's happening to calcium levels in the 7 lakes in the northeast part of the watershed, 7 small lakes that the ministry has been sampling since actually the late 70s. And you can see there's been about a 35% decline in calcium with very little variation among the lakes. That's what that little vertical bar is. It's not the percentage decline that's really important. What's really important is the levels of calcium in the lakes now And half of these lakes now have less than 1.5 milligrams per liter, 1.5 parts per million of calcium. And that's a level at which calcium-rich animals in the environment start dying. And that is actually widespread across the watershed. We're actually fortunate that a lot of people have been sampling in Muskoka, sampling lakes for a number of years. So recently, Carolyn Reed and her professor, Sean Watma, gathered all these data together from 590 lakes, from the district records, the Dorset records, and actually about 350 of these lakes were sampled by academics, including me. I sampled about 280 of these lakes with the help of a number of students. And I just want you to look at the number of red dots on this map. So lakes, each dot indicates a lake, and there's 590 on this map with dots, but about half of these lakes have less than 2 milligrams per liter of calcium, those in red. There's a lot of them in the northeast part of the watershed in Algonquin Park, but there are red dots scattered throughout the watershed. Those are lakes where the calcium is less than 2, and where animals like crayfish are in trouble. Animals like the little water fleas I work on are in trouble. Why are calcium levels falling? It's more than likely a small amount of the calcium in lakes comes from rain and the atmosphere. Those atmospheric deposition rates of calcium are actually falling, but most of the calcium in lakes comes from the watershed in stream flow. And if the levels are much lower, which they are, that suggests calcium levels in the soil have actually fallen, which they have. And maybe plants growing on the land, like animals in the water, differ in their calcium requirements, and it turns out that they do. If we compare calcium levels in maple and birch and a conifer, just look at these numbers here. Maple have 3 times as much calcium in the wood as birch. And 5 times as much as conifers, 10 times as much in the bark, and by comparison to conifers, twice as much in the leaves. So if maples, from the standpoint of the risk of low calcium, are kind of the crayfish of the forest, they're the species that have the highest calcium requirement emitting plants. And in fact, across eastern North America, there's widespread decline of maples, and calcium decline is the most likely explanation for that. Do we actually have evidence that calcium levels have fallen in the soil? We absolutely do. The old Air Resources branch of the old Ministry of the Environment sampled 3,500 acre plots, and you can see those, every dot here is a plot that they sampled every couple of years, sampling the trees. And between 1985 and 2005, there was about a 20% decline in the calcium levels in the sugar maple leaves. And that was associated with the dramatic 60% decline in calcium levels in the soil. And the maples with lower calcium in the leaves, those were unhealthy maple trees. And the dominant reason, I suspect you'll know by now, is acid rain. Acid rain has stripped about 0.5 ton of calcium per hectare from our soils, and we didn't have much calcium to start with. So how does this all play into what the Friends of the Muskoka Watershed does? Here's our little approach to our work again. We start by tracking threats to the watershed. So I've just shown you that 50% of the lakes in the watershed have calcium levels now low enough to threaten aquatic life. And and that calcium levels in the soil where the lakes get their calcium have also fallen dramatically. So we've picked this issue because it's widespread. It affects 50% of the lakes, most of our forests. And we think we can do something about it locally, which is to add the missing calcium source. And that's not something that governments are currently doing, but the public can help us with. So what are the knowledge gaps? Before we actually would launch a program to solve calcium decline in our forests and lakes, what do we need to know? Well, we do need to know if wood ash would actually work. So we need to know how much calcium is in the ash, How big a dose of ash would we need? Do we actually have enough ash to begin to deal with this problem? Are there risks? The forest managers that I talk to are very worried about metal contaminants in the ash. Can we prove there are benefits? There's a paper just come out of Quebec showing a 20% increase in wood production associated with the addition of ash to sugar maple bushes in Quebec. These are kind of the environmental science questions, but there's environmental psychology questions as well. Would the public be willing to share their ash with us? And then there are kind of engineering questions. How do we process it? How do we add it? That kind of thing. But before we can address those, there's a financial issue as well. So having picked calcium decline as the most widespread issue that we think local involvement can help us deal with, we approached the Ontario Trillium Foundation and they agreed with us, giving us first a seed grant in 2017 and then a grow grant in 2019. And that allowed us to begin to answer those questions in the big yellow bubble. We did that by striking research agreements with 3 universities, and I'll tell you about that in a second. And then we started doing all kinds of polling and social media work and marketing and education and outreach. These are all the things that we think we needed to do to help fix this problem. So let me just answer a few questions for you and show you how we're doing. This graph, we started off just asking the simple question, is there enough calcium in the ash? So here is a plot of nutrient levels in wood ash. It's kind of better than limestone because it's got more than calcium. It has other nutrients, potassium, magnesium, sodium, phosphorus. But it was 30% calcium by weight, almost as good as limestone, which is 40%. The other thing we really liked was there was very little variability between different contributors of ash. So this little range from about 27% to 32% ash is the range between 10 different people that gave us ash from their fireplaces. This gave us the confidence to start. So we launched the Ash Muskoka project with funding from the Trillium Foundation really just 2 years ago, or maybe if you allow for COVID interruptions, only kind of a year and a half ago. And we had 4 main objectives: to encourage the Muskoka public in getting engaged in environmental restoration. Trillium doesn't fund research. Trillium funds public engagement for public good. So that's our main goal, to get the public engaged in restoration, to develop Canada's first non-industrial wood ash restoration project designed to solve a problem of calcium decline, and then to answer several of those applied questions that were in that big yellow bubble up on the right. How do we do it? How much ash do we need? Can we prove that it works? All that stuff. So one slide that you can just read. If we are successful, and I believe we will be, I'll highlight a few things. That we should end up with a healthy, more vigorous forest. And that's because it's calcium lack that is responsible for widespread maple decline. What we've learned along the way is that if the trees are stronger, they'll actually be more resistant to climate change, defoliators, windstorms. We didn't know that at the start, but it's all true. Perhaps most importantly, of late, we are able to show an increase in wood production if we get rid of the calcium decline problem. And that means there's increased carbon capture by the forest. We have about 300,000 hectares of mixed hardwood forest in Muskoka that captures about a ton of carbon per hectare per year, and we think we can increase that by 20%. Perhaps most surprisingly, we think there might be a link to spring flooding, because calcium-limited trees don't pump as much water as they normally do. And if we can get calcium levels in their leaves back up where they should be, the stoma of the leaves work better, and they actually pump about 20% more water, which means the landscape will be a little drier in the fall and should be able to hold a little more water. So who's involved in this project? There's a bunch of people. The Ontario Maple Syrup Producers Association had independently discovered there was an enormous problem with calcium decline in their soils. So we're working closely with them and in 3 of their bushes, thanks to Ken Riley, Mark Lupton, Will Kreeser. The district has been great helping us collect ash at the Rosewort Transfer Station. The Dorset Environmental Science Center helped us do a bunch of initial toxicological stuff and have helped us with analytical support. I'll talk about the universities in a moment. The Muskoka Steamship and Discovery Center has been helping with public outreach. The forests at Camp Big Canoe have welcomed us to do our larger scale ash addition, and I'll show you that at the end. And we're beginning to work closely with Westwind Forest Stewardship, who we hope will help us roll this out down the road. We struck research agreements in our first year with 3 universities. Dr. Sean Watma, the director of the School of the Environment at Trent University, is Canada's expert really on the effects of calcium decline on hardwood bushes. We are funding a number of graduate student projects that he is leading that will tell us what ash doses are needed, hopefully prove that there's no risk for the trees, but benefits. And he's just started work on sap quality, which the sugar bushes are very interested in. They're bending their rules a little bit and allowing us to send money outside of Ontario for work that would be done and would benefit Ontario. So he's Canada's premier environmental psychologist, and we're working with him to help us identify barriers to public participation in the project. And Dr. Chantal Berriot from Laurentian they have an internship program of their master's students, and one of their interns has developed a video working with us. But the most important participants are you, people in Muskoka by the hundreds that have stepped up to the plate to agree to share their ash with us. Won't it be nice when we can see crowds like this again in Muskoka? So how is it going? You are engaged. There are hundreds of you, 700 plus, that are sharing your ash with us. You're bringing your ash to us at the Rosewarne Transfer Station. If Peter Kelly is on the call, he said he wanted one joke, so I included this picture. Here are 3 members of our board at our last ash collection in December. It's dirty work screening the ash, but we have to screen the ash to remove all the particulates. Then we trucked the ash, this is in the fall of 2019, to the 3 sugar bushes. The picture on the right here, that's about a ton of ash that's about to be spread on a whole bunch of plots in Ken Riley's sugar bush. With the help of lots of volunteers, we very carefully weighed out this ash. And then with the help of 3 students here from Trent University and a whole bunch of other volunteers, we trucked the ash into the bush and we spread it on a whole bunch of plots at very carefully monitored doses. This is what 8 tons of ash per hectare looks like in gray, spread on top of the leaf litter in November of 2019. I'm going to share 2 sets of data with you. And here is the first. It's pH data from 3 layers of the soil in our averaged across the 3 sugar bushes. So there's a lot of averaging here. So we sampled the litter layer, that sort of partially decomposed layer of litter called humus just below it, and then the mineral layer of the soil. So 3 layers at 5 locations in each of 5 plots, in each of 3 treatments, in each of 3 sugar bushes. There's this, so this is an average of hundreds of samples. And this is pH. The lower the number, the more acidic the value. And it's pH, it's logarithmic, so a unit of 1 is 10-fold. So this shows that the 4 ton per hectare ash dose raised the pH in the litter layer of the soil from 4.5 to 6.7, a 100-fold reduction in acidity and even more than 100-fold with the 8-ton per hectare dose. So dramatic reductions in acidity associated with the addition of ash in the top 2 layers. And this may not look like that much, but this is actually a dramatic reduction in acidity in the mineral layer as well, because this is a logarithmic scale. And that's after 1 winter and a spring. So what might that mean, the change in acidity and the change in the calcium for the plants? I'm just going to show one set of data because Batul hasn't released the other data to me as yet. It takes about a year and a half for graduate students to be completely content with their data. But these data are very promising. It shows the percent increase in calcium levels in leaves, shoots, and roots of maple after 1 year, a 50% increase in the leaves. That means the stoma are working better. Photosynthesis is going up. More water is being transpired by those leaves. 100% increase in the shoots. The shoots of plants are like our bones, and they take calcium to strengthen those shoots. So this means potentially more wood being added. We now know in mature trees, there's a 20% increase in just the production of wood. And the roots, 175% increase in calcium levels in the roots, which means the roots are healthier, more fine roots, more mycorrhiza. All of this is very, very encouraging early data. With that early data, we then moved to Camp Big Canoe. And here are 4 other graduate students from Trent University adding ash to Camp Big Canoe last November. So where are we with this? We chose calcium decline as our first stressor. We've answered a number of the questions. The ones that I've grayed out are pretty well answered. We don't quite know what doses needed yet. We're going to be comparing 2, 4, 6, and 8 ton per hectare doses. And as you saw from that picture of Neil, Peter, and me, we need to improve our ability to process this ash so that we can add it in a more mechanized way. The academics are doing brilliantly in their research contracts with us. It'll then be up to us to take the knowledge they generate and work with policymakers and forest managers to roll this out. In the next 5 or 10 minutes, I'm done with the Pass the Ash, and I'd like to talk about Hold the Salt. This is an initiative that the Friends of the Muskoka Watershed is just starting. Here's a pallet of 250 kilograms of salt that I snapped this picture of in my local market. So what is the story with chloride? The District of Muskoka samples 160 lakes and water bodies, as you know, across Muskoka every couple of years. They measure chloride. Chloride levels range by 700-fold among Muskoka lakes, from about 0.1 milligram per liter of chloride to over 100, an enormous range of chloride among these lakes. If you ask, where's this chloride coming from, the first way to address that is to ask, what is it associated with? So here on this vertical axis are the calcium levels and the sodium levels associated with chloride in these 160 lakes sampled by the district. There is a very weak relationship with calcium. The black squares are all over the place. But look at those red dots. They're on a perfect straight line pretty well. Sodium explains 99.5% of the variance in chloride. And the slope of the line is almost 1, 0.983, and it almost goes through 0. So a way to summarize that equation is sodium equals 1 times chloride. All of the chloride is associated with sodium pretty well. The other clue to where the sodium chloride is coming from is to look at the lakes that have really low chloride and the lakes that have really high chloride. The lakes in green with really low chloride, all levels less than 0.3 or 0.4 milligrams per liter, are remote. This is up on the Limberlost property. Most of the lakes that have high chloride are right beside Highway 400, right beside Highway 11. And then there's a few others we need to explore. This is Tuke Lake, and Much of the watershed of the Brunel Road is in it. Sparrow Lake getting its flow from the south, and I'm not quite sure what's happening in Ada Lake. But it's clear that almost all the lakes with really high chloride, the highest being Jevons, are right beside highways. So this is road salt we're looking at. How much salt is too much salt? Well, the Canadian Water Quality Guideline is actually 120 milligrams per liter. We don't have lakes with chloride levels that high, but that is a completely inappropriate standard to apply to Muskoka lakes. Dr. Shelley Arnott and Martha Sella Salgado from Queen's University have asked the question, how toxic is chloride to 6 different species of Daphnia in soft water lakes, in lakes that have calcium levels as low as typical Muskoka lakes? And the answer is, if the chloride level is around 10 milligrams per liter, or perhaps 30 or 40 milligrams per liter, these animals die. That's what an LC50 is. This is the concentration of chloride that kills half of these native species in the lab in 21 days. And if the chloride is more than 10 milligrams per liter in waters like ours, these animals die. So if we go back to the district's chloride data, 25% of the lakes have more than 10 milligrams per liter of chloride. Now, the calcium threat that I talked about earlier applies more to lakes in Algonquin Park, the northeast part of the watershed, but the chloride problem applies more to lakes in the developed part of the watershed. If you look at Lake Muskoka, for example, and ask where's 10 milligrams per liter of chloride, you can see that in Muskoka Bay or Gravenhurst Bay, chloride levels have been rising and are now, according to the district's data, above this 10 milligram per liter threshold at which water fleas that eat the algae start having trouble. Levels seem to have stabilized in the main part of the bay at around 6 milligrams per liter, which of course is much higher than the levels were historically, but it means that the lake is kind of in balance with inputs and outputs right now at about 6 milligrams per liter of chloride. I think things are dying, would be my guess, in Muskoka Bay. They may not be dying yet in the main part of the lake, but how much road salt does that actually represent? I just thought you can take the chloride levels in the main body of Lake Muskoka and know that it's all associated with sodium, and calculate, given the volume of the lake, that there's about 15,000 tons of road salt in solution in Lake Muskoka right now, which is about 1,200 salt trucks worth, or 60,000 pallets that look like this. It's about 1 pallet for every permanent resident in Muskoka. So the more salt we use, the more damage we might do. The more salt we use, the safer we think we are, but wouldn't it be nice if we could maintain safety and reduce the use of salt? So let's go back to what the Friends of the Muskoka Watershed would like to do. We're picking road salt as our second issue. Calcium decline affected half the lakes in the watershed. We think road salt is threatening about 20% of the lakes in the watershed. It's the bigger, more developed lakes that are threatened by road salt, including Muskoka Bay. To deal with it, we have a number of issues, a number of knowledge gaps that we have to plug. We need to know what salt load will get Muskoka Bay back to 10 milligrams per liter. What are the key salt sources? Is there some tool that we can develop which would make it easier for citizens to track the use of salt? We think there is. Would the MLA help us monitor salt levels in the lake? We think they probably would. At least Chris Cragg has told me that that's quite likely. Is the public aware of this threat to Lake Muskoka? We think likely not as many as should be. So we are at the stage where we're seeking funding to try and launch a program which would resolve these questions, these knowledge gaps, initially for Muskoka Bay on Lake Muskoka. Okay. So road salt is the Friends of the Muskoka Watershed's next focus, and our goal will be to eventually get Muskoka-based chloride levels back to 10 milligrams per liter. I think together we can pass the calcium and hold the salt or halt the salt. And I certainly would like to invite members of the MLA to join us in this effort. And I thank you very much for listening to me for the last half hour. And I'd be happy to pass the mic back to Penny and to Penny.
Thank you very much, Dr. Yan, for your presentation. I do have a couple of questions, and you may have some previously sent ones as well. Did you want to answer those ones first?
Sure.
Okay.
By the way, I had a message come up a few times that the internet connection was unstable. Was that all okay?
At times we find the Wi-Fi up here, it doesn't work. So we do have that concern.
Okay.
I did hear your voice garbled a bit, but you were quite clear for the majority, for me anyways.
Okay, thank you. Yes, we did receive a question or two, so I'll try and address those first. Bill Tryon asked about calcium chloride versus sodium chloride. Might it be as negative? Calcium chloride, of course, is used for dust suppression on gravel roads, whereas sodium chloride is used more for winter salt melting. The answer is that the chloride associated with calcium chloride can be as problematic, but there isn't nearly as much of it in Muskoka lakes. You saw that the chloride was more associated with sodium than calcium. And calcium chloride has one distinct advantage, and that is it can help solve the calcium problem by adding a little bit of calcium before it creates a chloride problem. Because you only have to get the calcium up above 2 milligrams per liter or so, which a little bit of calcium chloride addition can actually provide, but that won't add enough chloride to get the chloride levels up to a dangerous level. We actually saw that happen in one of the Dorset Environmental Science Studies lakes, Dickey Lake. It was the only one of the 8 main Dorset lakes that did not show that consistent decline in calcium that I showed early on, that 35% decline. The calcium levels in Dickey Lake actually over the course of the 40 years have not declined, and that's because of the addition of calcium chloride to the gravel road around the lake. And so it didn't have the calcium problem, but the chloride levels didn't go up enough to be problematic. So that was a very interesting kind of accident.
Dr. Yan, before you answer the second question, I'm just being mindful of our time. I did have several questions, if I could interject, that came up that were quite similar, and it's a good one. Is it safe and good to add wood ash directly onto or into the lake or the ice?
I assume people want to do that in part to minimize the risk of fire associated with putting hot ashes in the forest, which I certainly, the first thing you always have to be careful of is to make sure whatever you're doing with your ash, it's completely cold. You need to let it cool for several days. I can't advise, even though I know this has been done for decades, I can't personally advise putting ash directly on the ice. And that's only because it's still considered by the Ministry of the Environment, Conservation and Parks to be a potentially hazardous waste. And so we don't want to be adding potentially hazardous wastes directly to the water. And now, 2 years ago, the Ministry of the Environment treated it as a hazardous waste and there were interactions with us, but then we analyzed it up and down many, many times for 11 potentially toxic metals, and they changed its rating from being a potentially hazardous waste to just being a solid waste. but they still absolutely insisted that we add ash no closer than, I think it was 100 meters from any water body. So all the ash additions we've done in the forest are well away from water. So in the mind of the regulators, they still consider it a threat, even though we kept on saying to them, we're actually fixing a problem here. So if I had a cottage on a lake, and I knew the lake had low calcium, I'd probably be putting my ashes on the ice if the lake had low calcium. But Lake Muskoka does not have low calcium. Please save your ashes and give them to us. We'll put it where it's needed.
Thank you. And you have your second question?
Okay. Actually, Bill Tryon asked 3 questions. His third one was about saturation points. Are we reaching a point where, and I assume he's meaning chemical saturation, and the answer is no. All of these chemicals are way below saturation levels. I don't know if anyone's ever heard of a whiting event. There are times where lakes where the calcium is close to saturation on a really hot day in the summer where the whole lake turns white. And that's because the lake has reached the saturation point at that temperature for calcium, and all the calcium turns into particles in the water, and you end up with a really weird looking white lake. He also asked, what else do we have here? Oh, there was a question about copper sulfate additions to septic tanks, and was that a good idea or not? Okay. Sorry, I just saw another question pop up, which is why I paused. I know that copper sulfate is sold as a blue granules, and it can be added to septic tanks. Personally, I wouldn't do it for 2 reasons. One is that copper is, of course, very toxic, and that's why people are adding it to kill tree roots. But it's also going to end up moving through the groundwater and potentially into the lakes. And that's not a good idea. The other thing is that copper is very strongly bound to organic matter. So the vast majority of the copper you add to a septic tank is going to just be bound by the organics in the septic tank and not actually be effective. Having worked for half my career in Sudbury, where the concern was getting copper out of the environment, I actually don't like the idea of adding toxins to the environment directly. I think that's all the questions I had, Penny, in advance.
Okay, I have one more. Are there negative impacts to raking and removing leaf litter?
Well, it kind of depends where you put it. Leaf litter, okay, we'll make it specifically tied to the calcium story. Trees do not pull the calcium out of their leaves before they fall in the autumn. So all the calcium that was taken up by the leaves all summer, which was used to keep the leaves healthy, photosynthesis going, pulling carbon out of the atmosphere, pumping water out of the ground, allowing the pores in the leaves to work properly. All that calcium is raining down to the ground. If you leave it there, that calcium will be leached into the soil and recycled back up into the tree. If you pull it all away somewhere else, you're increasing the rate at which calcium is lost from the watershed. So I personally believe there is some specific negative consequences of raking the leaves up from the under trees and putting them somewhere else. Now, if you turn them into leaf litter and then spread that leaf litter and turn them into humus or compost and spread that leaf litter compost back into the forest, there's no net negative effect.
Okay, thank you. And I think we have time for one more question. Are the calcium levels in the 3 big lakes as low or as bad as the smaller lakes in the watershed?
Excellent question, and the answer is no. Calcium levels, we have data going back to 1983 in Lake Muskoka, and it actually looks like calcium levels now today are about what they were 40 years ago. The reason for that is that people have already been adding lots of calcium to the watershed in the form of ashes, for example, or other sources. So at Brandy Lake, for example, they take all their wood ashes for the year and pile them in a snowy cul-de-sac on a road. And they do that to avoid fire risk in the snow. But all that ash is 30% calcium, ends up back in the groundwater, and has kept the calcium levels in Lake Muskoka, Rosso, and Joseph up when natural calcium inputs have declined. Calcium levels in the rain are actually 25% lower than they were 40 years ago. So these two issues that I talked about today, calcium decline is more an issue in the northeast part of the watershed, although scattered elsewhere. Road salt is more an issue in the southwest part of the watershed associated with roads.
Okay. Well, thank you very much, Dr. Yan. This is all the time that we have for now, and I'd like to thank our participants today for joining us. I understand that the wood ash drop-off has been suspended due to COVID at this time, and we're looking forward for that to continue. And you'll be putting out, I'm sure, a news flash, and we can certainly support you with that, Norm.
Thank you very much. We're actually hoping we can have one on February 20th, but it may, certainly the January and 1st February one have been canceled.
Okay. Thank you very much, and have a good evening, everyone. Thank you.